Well, good. Well, hey, I appreciate you guys having me out here tonight. So our topic tonight is going to be a discussion around how to speak the language of application architecture. Okay, so we're going to touch upon quite a few things here tonight. So I'll kind of give a little bit of an intro. We'll talk about the software architect role, because that thing seems to move around and have different things morphing with it. We'll talk about continuous design and application architecture, design principles. We'll go over some things that are related to generic models. And we'll talk more about modeling your software. Talk a little bit about design patterns. And something called an architectural review board. And then finally, we'll go into a little bit of EA, enterprise architecture, and frameworks that are around it. So without further ado, let's go ahead and jump into this. So, as mentioned, my name is Brad Bierman. I work for a startup downtown. It's called Kapow, and we get involved with corporate events management. And we have a platform that manages that, and it is actually built on the Ruby on Rails stack with MySQL, and we got React in the front end, and a lot of other fun stuff in the middle that make up our technology stack. And I work as the director of technology. I've been there for close to a year. But prior to that, I also own a website called ProfessorString.com, which is a website I've had for about 10 years or so. It's dedicated to guitar strings. And so I also hand wind them and have a company up in Wisconsin that helps me do that. And so we've wound strings for celebrities like Carrie Underwood's guitarist. We did some strings for Prince, reviews around and stuff. So yeah, all the fun stuff that goes on with it. So ProfessorString.com. So check that out. So that's enough pimping of that. So a little bit about Kapow. Again, we're in the corporate event space. We've had 1,000 customers. We've done 5,000 events and different experiences. What we kind of bring to the table is, instead of going to just a hotel for a large sales event or just doing the regular steakhouse, kind of offer some different experiences. As I was talking to Ron, I said one of the things we've got is, if you have a corporate event that you want to do that's a little different, we offer something that involves axe throwing, archery, pizza tossing. We even have adult tricycle races. We've partnered up with companies such as Nike, which you can go to a Nike store and have a corporate event hosted it, and Nike absolutely loves it, because you can walk into just a shoe store, there'll be wine, cheese, food, presentation, everything's set up, and so it works out really great. We've really established quite a platform for that. But the big news for us really came about a month ago. And this was the headline right here. So we actually just got bought. Cvent, which is the largest company in this space, they're about $1.8 billion in size, and they came in and bought us, and we were about 50 employees, and so a very exciting time for us. And so Kapow started about 6 years ago or so, and we were actually out there looking for additional funding, and Cvent says, man, you guys got a great thing going. You got the #2 office space in Chicago. That's actually a picture of our front office and everything. Yeah, we like to capture what an event kind of looks like, so we got our moose bar and everything else. So anyway, after that, let's get into the stuff. Okay, so software architect role. This is an interesting role because it's changed a little bit over the years, and it's often broad in what it encompasses. Kind of 4 buckets that it really captures, and so we've got things that focus on applications, so really the designs and structure of applications. And this is where you'll see something like the software architect, app architect, or framework architect. All right, and then we've got folks that are sales and support. One time I worked as vice president at Oracle, and I had close to 30 what they call solution architects reporting to me, and we would go out in the field with our architects and help assist customers with the implementation of the product. So as a solution architect, sometimes also known as a field architect, so very popular in the licensed software area. And then of course the systems, skill and infrastructure design. This is the big one right now, cloud architect. Okay, so we've made a lot of changes from infrastructure architect, system architect, and of course operations. Skilled in the operations of the enterprise architect, and integration architect. So those are just kind of some of the roles. I know everybody's kind of seen those over the years, but they take different shapes and forms. That we're going to focus on these 2 and the discipline that's around. So what are the essential skills to really become software architect, so to speak. So familiarity with an architectural modeling language is a key piece. Fluent in creating diagrams and visual feature representations. You got to be able to do that. Familiarity with a framework like Togaf Adm, ITIL. We'll get into those in a little bit. We'll also want to talk a little bit about, hey, just comfort around a code base. You might not necessarily be a developer as an architect, but you could be around the code base. It varies depending what you're doing, but you've definitely got some experience as that walking into that role. So your key thing here will be to present a vision of how something is built in a holistic way, and also derive cost effectiveness designs and options for as you build a platform. Okay. Debates and symptoms. Now, this is kind of interesting talk here because growing and mentoring architects, it's not really happening at the level today that we see probably some years ago, particularly as things were more waterfall, more a longer design period and that were going longer. So that role really became more prominent. Today's architect, really don't see a lot of that happening about, hey, how do you grow that role or something there? Because now we're just doing our work in little snippets. We're doing little releases. This thing called Agile came along. And so the role took a little bit of a different turn there on how it was grown. And the other thing too is, it's kind of hard to measure design as an investment. And as I got a friend of mine that sells architecture roles, he said, it's really not much different than selling vitamins. Okay, so it's something we know we should do. We know we should put design in things, but in a rush to be agile, we'll get right into the code and do this small 1-week sprint, or this 2-week sprint, or something. We really haven't put down anything diagrammatically. We haven't put anything visually. We maybe just did some envisioning, and boom, code starts coming out week after week after week after week, year after year after year. Now you've got this massive code base, perhaps possibly with no design documents around it at all. Everything. So that's a sticky wicket. And why is it that way? Well, some folks think design slows development. Okay. Oh, I got to take time out to do this. That's just slowing me down. Or here's my favorite one. The code is our documentation. It just tells you, just go read it. You know what it does. Okay. There's what runs. So, but it really doesn't describe things. We'll get into that. Okay. In Agile development, yeah, the envisioning step really not being done correctly the way at least it was intended in the original manifesto. The design discipline guidelines, principle number 11, very loosely defined by design. That's the way we wanted. We didn't want to dictate how people should design stuff, but it also has kind of manifested itself into that step could be somewhat skipped a little bit, just a little bit of a discussion between you and I. That's how we're going to do it. Okay, let's go. And boom, that's how it kind of starts. And so code delivery ends up being prioritized over design. And so what we end up with is a complete abandonment of our architectural skills that we really had in waterfall. And that so oftentimes I find a lot of developers that just basic UML, don't know the principles around that, how to diagram things. We'll get, again, more into this. And this is an interesting thing here. So I almost took this from Simon Brown. He says, it's an industry sacrilege to say anything bad about the Agile Manifesto. But it has some gaps. It has some gaps. Nothing's perfect, right? Okay. Going from a developer to an application architect. So as I've worked with developers, I have a group that reports to me, and I have folks that come in, hey, Brad, I'd like to be an architect. I've been in development for a long time. I'd like to go more into that role. I said, well, there's a bit of a mind shift that goes on with this. So as a developer, the nature of your work is more instant gratification. I write something, it maybe runs and renders, and I get to see the results right there, instant. I get to see it. Okay? In your application, success is measurable. Okay, your product is a code base as a developer. The code is viewable. You can actually see the code as a developer. Okay? It's low abstraction. There it is in front of you. A little bit different as an architect. So the nature of the work is more of a delayed gratification. The success of architecture is hard to measure. Your product is a vision. Your product is a vision of why something is being put together. It is something that is somewhat invisible to us, but it's omnipresent. Even in this room, just from construction, we've got architecture here. How is it put together from an architect perspective in that it's something that's not really visible? We see the end product of the building, but what was down in the blueprint, what was the thinking in that? So a little bit of a vision that got us here to what this architecture ended up being. So a bit of a higher abstraction in this role. Okay? So where do you start as an architect? You'll start by thinking about being design-driven. Okay? Design-driven is where you want to go. Step 2, well, yeah, be design-driven. Start there. Ease into it, don't rush. This is a discipline. This is a discipline of being an architect. Think about how something, a business, consumer works, and the strategy behind it. This is a kind of thinking role, it's a strategy type role about how we're going to build something. Resist the urge just to hurry up and draw something or rush into patterns. I've seen folks get in this just, well, I feel like I got to draw something. I'm the architect. I got to get up at the board. Throw me a dry erase marker right now. I got to be able to do something. Take your time, man. It's a vision. That's the product. And this takes a little while to evolve in that. So again, a bit of a discipline going from, I'm writing code right now, boom, there it runs type of thing. A little bit of a delayed gratification that goes on this. So very strategic in nature. And it involves articulation. It's easy to overwhelm an audience. Hence the cartoon. Okay, now that you have an overview of the system, now we're ready for more detail. Come on, give me a break. Think big, but start small. Little pieces. Kind of like what the manifesto was about in Agile. So get the big picture, get the holistic view, but let's start in small pieces here. And then start to segment and decomposition that down. So code versus strategy. Our code tells us what is being done. The code is merely a set of instructions. That's what it is. Okay? Architecture tells us why something is being done and how it is being done. The architecture is a vision and strategy again. So for folks, I like to say, hey, the code, that's our documentation, that's our base. Well, it really doesn't address why are we doing this? Or how is this to be done or anything. So again, just the code is a set of instructions for a process. Yeah, so again, thinking at those higher levels here. So one of the things that we started focusing on here, at least as I've come on board at Capal, is something called continuous design. And we'll go a little bit into this. Those of you that were around during the dot-com boom, you'll think about around like 1999 or so, there was something that came around that was called extreme programming, okay? Very popular at the time. And this was starting to come right after Agile, okay? And so it had this thing in it called continuous design. And this is the practice of creating and modifying a design of the system as it's developed, rather than purporting to specify the system completely before it starts. And that's the whole genesis of where really Agile came from. Is there was an interview with Martin Fowler. He said, where did you guys really start with this when you were up in the ski lodge, 17 of you? He says, well, we were having this huge dialogue about extreme programming. We just need to really get this into some type of quantification here. We're 2 years into extreme programming, and that's really where Scrum came from, was the extreme programming part and having this continuous design, okay? Continuous design was popularized by extreme programming. Continuous design also uses test-driven development, which we use a lot today in refactoring processes. Okay, so that's about where that piece came from. Back in '99 is when this kind of started. The manifesto came around in 2001, and so we've seen where it's coming out today. And so that was kind of the genesis of where this comes from. Today, we see different companies taking on and saying, oh, we're 100% Agile, whatever the hell that means. Some companies are saying, well, we're on the move from waterfall into Agile. Okay, so right now it might be Scrumfall, or water Scrum. Who knows, whichever you call it. It's a mix of the two. Some folks have gone from waterfall. They tried to go 100% Agile, maybe got as far as they went. They said, you know what, this thing has got some gaps. I'd like to hybrid this thing. And that's a move we're starting to see as Agile is now, well, we're kind of approaching 20 years on this type of thing going on. So it's been with us for a while. So people are really starting to embrace a lot of the hybrid delivery frames here. And so it's a mix really of both. We still love the things that we saw in design in waterfall. We still love the things that were analysis in there. But it doesn't work to spend the next couple of months working on that. We still want to keep this practice, but yet we still like our agility here to be able to do iterative coding, small releases, quick deployments, and things like that. So how do you get this to work together with each other? This is how it kind of works. Okay, so as you've seen this here, this is actually our life cycle at Capal. When I first came to Capal, it was a 1-week sprint. Okay, that's kind of tough. And as I came in, 70% of the points would roll over the following week. Sound familiar? Yeah, we've created a new waterfall. Roll over. And so it was a real problem. And as I brought in younger engineers, people that had less experience, onboarding them, absolute nightmare, because there was no documentation around the code. Here's a code base that had been going on for 4 years, not one single document. I had 2 developers, lead developers. It's all up here. It's all up here. Just go talk to person X, person Y. Well, person X and person Y, I'm managing them. I know this one's about ready to leave, so there goes the stuff out the door. We've got to do something to get on top of this right here. And so, continuous design, let's borrow that chapter out of extreme programming. I put it right here, stretch it out to a 2-week sprint so that allows us to start thinking about this. It's called Design Just Enough to get through the sprint. In fact, there's a popular book out by Simon Brown. We'll talk about one of his models here in a little bit. It's a book called Just Enough. And that's what it's kind of addressing. Just enough design to get through the sprint. But now you've got a running document. You've now got a running artifact. And what we do in this is we'll create a Crutchton 4+1. We might do a little bit of UML modeling. We might do a C4 model. A couple of things. It continuously lives with the code. Okay? We could just write the code and not do this. But what I found is as we start doing these diagrams and we start to build in, getting somebody onboarded, man, did that become a lot easier because I just put some diagrams in front of you. See, here's how this process works. Here's a sequence diagram. Here's a Crutchton model. We'll go into that in a little bit. So what that means, huge help, absolute huge help. As a big success, I think, for a lot of junior programmers. One of the challenges we've got today as an industry is when you go out there and look in the job boards, 90%, we usually want somebody that's a senior developer. What happened to the junior? How come nobody wants a junior anymore? These code bases have become so complex and things, and not everybody has documentation on it. You've now backed yourself in a kind of corner. This is so complicated. I've got a big ball of mud I've got to really dig into. So we've got to find some way to nurture these folks here. And so this is kind of the cycle. We spend just like maybe a day or 2 on this, and we'll go through. We'll do our sprint planning. We'll do our grooming around those things. Do the development. And you guys have seen this if you've been in Agile, okay, the typical rest of the cycle in that. So that's how we're kind of working in the 2 weeks, making sure that that continuous design piece is in there. And that's really the focus of what we're talking about. As I started working with the team, I found a lot of folks that are, I'm going to say that were not around during the .com, that were not around kind of the early days, heydays of waterfall. Things like UML, those disciplines really aren't taught anymore. And so we've kind of lost a little bit of that. Continuous design principles. So incremental design just enough, again, to build the sprint, but build upon the application's holistic view. And that's what you end up with. As you keep going down your sprints and building up your design doc with it, pretty soon over time, not only do you have a built-up code base, you've also got the design built up with it, too. And so one of the key successes for us is as I pushed this forward in December, we were getting audited. I didn't know it was really an audit, but it was called Diligence Phase when we're out there trying to get funding for Kapow. They came in and wanted to see, hey, how'd you put this together? And what they were fully expecting was to see no documentation and hit the reject button, as what they've done with 98% of the folks out looking for funding. When they came in our shop, guess what I had them ready for? All these design docs out there, and I just handed it over right there. But we passed right through that, and they said, we want to talk. Pretty soon, a couple weeks later, we want to buy. And that's a huge difference because that allowed an investor to come in and see, oh yeah, I get it. There's some discipline around this thing, and I visually see what's going on with it. So build confidence in your funding cycle. Build to change instead of building to last. That's a key part of obviously being Agile, but not to say we're going to go out there and spend all this time on design, but again, just an incremental piece, and it's always going to be changing. So nobody has to stay up on these diagrams either. Just get the latest one we've created. It's always continuously going, okay? Model to analyze and reduce risk. Use design to identify key engineering decisions. This helps with cost, obviously, maintenance, whatever else. Recognize delay gratification. That's really in the design, okay? And use models and visualizations as a communication and collaboration tool. That's key for your continuous design principles, okay? I first started to have some engineering people come up and say, all right, well, I guess we'll get up the board and draw a picture of what this kind of looks like for you. And I'm like, wait a minute. We're going to draw a picture, or we're going to draw a diagram? Just even the lexicon has been lost. picture. This is a picture. It's worth 1,000 words. This is a diagram. Diagrams are right to the point and often should be a few words. Boom, succinct, focused on one thing, right there. We don't want it to be interpretive. It's got to be a specific segment and get to a point of what it is. And that's really kind of one of the things we want to look at here. And so, Simon Brown, I said this guy's name a couple times. This is really interesting. Far too many teams allow their code bases to grow without having an insight into the structure of the code. The result is often the proverbial big ball of mud. Code base that's tangled, hard to understand, hard to work with, and hard to change. This is the key phrase right here. Visualizing the structure of your code is the first step towards improving it. Isn't that true? If you can't visualize it, where are you going to start? Where are you going to start? You know, it's tough. And so one of the things Simon Brown does is he goes out and consults, is he goes out to these big Fortune 500 companies and takes the lead engineer or lead architect, please draw me what your code base is right now. These are actual drawings he gets. One of these is actually from one of the, I'm not going to call it was somebody from Baxter. So there's a Baxter who really kind of heads up a lot of the development there. I don't think he's on there. One of these is his. There's actually somebody from a couple, it's just interesting. I'm not even going to say who these folks are. But look at this. This is somebody trying to communicate to maybe somebody like you what their system is. I mean, these are some real masterpieces. Like, what is this? This one here is actually my favorite. It looks like it's structured. What the hell is a functional view? I've never heard of that as an architect. There's no formalized thing called a function view. There's nothing functional about it. There's no communication. It's just some boxes or whatever. This one was actually drawn by the company's CTO. Okay, and so, okay, there it is. And so what's going on here? Again, our ability to visually communicate our code structure, we've kind of lost some of that right there. And so I'm going to show you a few tools, a few models that you can use to start into this thing. Okay? So our quest to become agile is lost ability to visually communicate our code. Right? So let's talk about some generic models. What can I dig right into? Just make this a little bit easier. So there's been an evolution of these models, languages, and notations. So if you've been an architect for a number of years or been around it, you'll notice, you'll recognize some of these things going back. And yeah, this has been talked about since the 60s, even with the invention of things such as Smalltalk, beautiful little object-oriented language, object-oriented design came around. Schlar-Mellor, this was also one of the first modeling techniques that came along that was based on object-oriented design. For those of you familiar with Grady Booch, you know who that is, but this is one of the things where we first started seeing the idea of use cases come around. OMT1, which is Object Modeling Technique 1 and 2, that was introduced by Jim Lumba out of MIT. He was also a friend of Grady Booch's. And so there was some competition between these two here about how to model something. And then somebody else jumps in the game, creates UZI, Object-Oriented Software Engineering, in 1992. And then this company called Rational showed up. And they created a product called Rational Rows. Okay? How many people have been familiar with that? Yeah, okay. Awesome. So it stands for pretty much a software package that's rational object software engineering. And what they've done here is these guys got together along with another guy called Ivar Jakobsen. And Ivar is often known as the father of the use case. That is where we actually first saw a use case come up. He is actually somewhere on this time frame too. These guys get together and create something called UML. Okay? And then we saw the release of UML 1.0. And then as we started to go into the dot-com movement, you started to see a lot of people using this language, and it stands for Unified Modeling Language. It really takes the summation of these and rolls it up right here in this standard. It's really ingenious, and it really has a lot of great intention behind it. The tool that you use is rows. You create your diagrams in this. You guys are familiar with rows, you know how it works. But some things started to change as time went on, because this whole thing, you know, this gets complicated. There's a lot of diagrams. And today there's 17 diagrams in UML. Okay, that's a lot. What the hell's going on with it? It's kind of crazy. But it worked at the time because we were still very much waterfall right here. So it worked in that design period. So then we started seeing extreme programming come about. So Here was this first notion of just doing incremental pieces of stuff and making the design continuous thing with it. And then, lo and behold, those guys got together and created the manifesto. Okay, then we started seeing service-oriented architecture. And then in 2003, IBM goes and buys Rational. And then somehow or another, the party kind of came to an end at that point, because Rumba and those guys were fabulously wealthy after that point. Says, man, that was great. Well, wait a minute, you just changed the damn industry right there, and now some company comes in and buys it, and now just kind of puts it off to the side because that was a competitor right there. And so we started, that was really kind of the last hurrah that we saw as far as the marketing, the publications, the daily stories about modeling languages. It's kind of a shame because we've kind of lost it since that time here. Different things have happened, but UML continued to evolve as a standard, but the tool of rows kind of disappeared. It was an expensive thing too. I remember I was at March 1st, we paid $250,000 in our license for it. Absolutely insane. Man, they were making money hand over fist, but we had some beautiful designs. We had walls covered with it. We invested a lot of money in it. And after 2 months of no code and beautiful design, we'd had it. That's it. Okay, so it was time to look at something else. But what it got there, what it got for us, is if you take a look at this right here, the arrival of modern frameworks, this is when we started seeing something like Rails, Spring, Django, Symfony. What are those? Those are frameworks of popular programming languages, you know, PHP, Ruby, Java, all that. A lot of the design behind that came through a lot of the design pieces here in this language to build them. And now we've got something we can go out there and quickly build with. We don't have to come put together all these complicated components in that. So now it enables us to go fast, really fast in our architecture, in our work. And so we kind of left that behind and just boom, now we're kind of out where we are today. We're going to talk a little bit about C4 modeling, business process notation, and what's going on with the latest here. But now we've also got the arrival of microservices, which is kind of a new design paradigm too. We'll kind of talk a little bit more about that. Okay, so right now we're going to focus on Crutched and 4+1 and the C4 model. Anybody familiar with what those are? Aside from reading the syllabus on this talk? Okay. It's always interesting when I bring this up, this Crutched thing, because when I brought it up to my team, it was just all blank faces. And I also asked them to get up to the board and draw something, and it wasn't much different what you saw earlier. So this is a useful thing here, because they've really embraced it, and we've sped things up. We're able to do more points in our sprints because of this, by the way, too. So what is this? So this was a model developed by Philip Crutched. Worked for Rational for a while, too. He was kind of one of the salespeople out there. There was so many damn diagrams in UML, he just wanted to distill this down to just a few so he could go out there and sell rows. But what he ended up doing here is creating a really nice abbreviated model that a lot of people latched onto. And that's why we call it the 4+1 model. It's a rather generic view of things, so it's several things. This scenario, consider this to be a use case or a story. And around it, I'm going to go ahead and create a logical view, a process view, development view, and a physical view. Okay, so I'm going to find out structurally what's my code, what's the process, the behavior as the user uses it, the implementation view, which is also how I view it from a component way, what interacts with third parties and stuff, and then this is my infrastructure view about what's this stuff running, okay, cloud-wise, server-wise, stuff like that. So I get a nice 360 around what's this use case or something, and it's great. It has been really good for describing a lot of different things, and so the scenario is really helping you capture the requirements for all the stakeholders. Think of this, your stories, epics, everything is around this thing, and it's really key for putting together all these views, because the logical view, it's designed to really address the end user's concern about what's being used in the system. If you're familiar with UML, in that logical view, we call that a class diagram. And in the class diagram, you just list out the classes of your system of what you're using. So we've captured what the classes are. Process view. For people designing a whole system, those of you familiar with UML, that's called a sequence diagram. I'll walk everybody through UML here in just a little bit too. Just these several diagrams. Okay, so we'll all know what this is, but just for you familiar, this maps over to UML. Development view, that's a UML component diagram. Okay, this shows how the modules are organized, reuse and portability. Physical view, again, this could be our network diagram and everything. So what we do is we take a Crutched. Every time we start our sprint, we'll do a Crutched and say, okay, for these group of stories here, what do we need to model out of this? Okay, we'll start looking at the process view. So somebody will go up to the board and start writing out a sequence diagram for that. Okay, after we've already got what the use case is. And then somebody might go back and draw the developer view. Oh, here's the APIs. I need to connect with this thing over here, Braintree to get my payment, all this other stuff. So we'll kind of start to show that. And then we'll start to abstract into what classes are we using in our current code base and start putting together a class diagram or something new around that. And we'll do that maybe from a conceptual diagram first, just give a holistic view of what it is. And then finally, my DevOps guy is always standing there and says, oh, we're going to run this on the EC2 instance over in such and such an AWS cloud right there. So we just got everybody engaged in this thing. And we got it visually mapped right there. And now people are going to go back. They got this reference in their head, this vision of what this is. Okay? One other model I want to point out too is a C4. It's not explosive. C4 is developed by Simon Brown. He started using a little bit of this around 2006, but really published it in 2011. His inspiration was Crutchton and UML. This guy was huge in the UML. I remember back in the day, he really was in the UML and stuff. And then as we saw the evolution go on with it, he felt, hey, there needs to be something a little different here too. So the C4 model, it's generic, just like the Crutchton model. It's visual, non-notational. When I say non-notational, I'm speaking in terms of like a language. Like UML is notational. BPMN is notational. We don't have to learn notation. It's just a model. Okay, and C4 consists of a hierarchical set of software diagrams, context, containers, components, code. That's really what this looks like. His inspiration was Google Maps for this thing. And when we talk about context, we're talking about a holistic view of something. When we're talking about code, we're talking about the street level view. So if we wanted to work our way backwards on the C4 model, if I started at the street view, this is my code. This is the most granular piece. I know where it's at. Okay? And then if I zoomed out a little bit farther here, I see that this road here is near maybe a KFC or a Remedy Car Parts or something near a Waterworks Valley. Okay, so I zoom out even farther and I'm starting to look at containers. Okay, this is code, components, containers, and then we're going to work our way over to context. Those are the 4 C's. It's a zoom model, if you will. Okay. What was interesting is Simon went through this. He asked people, where's this road at? It's almost like you going in the code base and say, where is this? What does this section of code represent? Explain it to me. And without the context of what the whole system is, without any type of representation visually, how do you get a good, accurate picture? It is really tough. Not only until you've been working with that code base for quite a while, do you know what it is. Okay? And so we need to have some type of context around this. And so we start looking and zooming out here. As he started using this example of this street, he said, where is this at? We started thinking, oh, it's by a KFC, Remedy Car Parts, it's over by Fern Valley, probably here in the United States, right? And as we zoomed out, it's in Jersey. You can stop by and say hi to Snooki. But as we look at this further, we found out, no, I need more context, and it's actually in France. It's an island off of France. Same thing with the code. I need to zoom out and find out where I'm at. So that's how we do this with the model. The model starts out as this. Take a look at what the overall software system is. Put your container on it. In other words, this is your client-side web app, server web app side, console applications, mobile apps, microservices. All those things go in a container. Okay? And then we start to componentize that and take that down to a code level is essentially where you head with that. Okay? I'm not going to go into the details of how to do it, but definitely check out C4 model. Okay. Also check out Crutchton 4+1. I didn't want to make the intent of this to teach everyone how to do it, but it's become more of awareness of how to do it. Okay. Those are the things. Modeling your software. 3 ways architecture design often happens. Ad hoc, no method at all. I just start going. It just evolves. I'm starting to write code. I should just start going. Or we go with an industry standard of modeling. Hey, I might use a C4, I might use a Crutchton, might use some notation. I'm just going to roll my own. Just get up there and say, well, I'm going to draw it on the board. This is kind of what it should do. And then let's start writing something around it. Not everybody might understand or not, but those are kind of the 3. But again, it's to show that architectures are omnipresent, but not always visible. Okay? Let's focus now on UML. UML is like quite an evolution. And along with that chart that I just showed, there's many things that actually contributed to UML. You had Moses, you had Soma, you had OpenOML. There was different things that contributed to. So what we saw here in the early stages is many different types of modeling techniques, many different types of models. You really need to standardize on this thing. And that's really what came together. And that's what Rumbaugh, that's what Buch, that's what Jakobson all got together. And they were known as the Three Amigos and released this UML 1.0. And this was something that was accepted by the object modeling group. And that was the standard. And since that time, we've kind of seen new releases of UML. But there really hasn't been anything else around it being done until we started to see SysML, which is a derivation of it. It allows me to do system architecture modeling. And I've started seeing some people use that in their cloud architectures. And so very handy notation for that. And then business process modeling notation. A lot of people ask me, hey, Kapow, which version of UML are you using? It's a good question. We're using 1.0. It's just a real simple thing. 1.0. And the tool we're using is Glyphy. And that's in Confluence. You could use Visio. You can use any tool like that. And what's interesting about those tools is if you go take a look at it, they're actually based on UML 1.0. There's a reason for this. As UML started to become more complex and things, the thing that they were trying to do with UML is if I could create enough diagrams that depict the whole system, I could generate software with it. And that's what Rose was essentially trying to do. Okay, so if I put all these diagrams together in UML, it would generate the code. And sure enough, you'd see that in the demo. It was interesting. What you created was a happy path of the MVC. Okay, you wouldn't see exception handling in that code. And that was always one of the things I wanted to see is like, how robust is that? And there's where they wanted to start taking UML. Well, let's capture the rest of that. Now we've bloated this thing out to just complete nonsense. And it's just too much. And it becomes so complicated. And it's a shame. But there are key pieces you want to learn how to do. Sequence diagram, class diagram, component diagram. Those are the three right there. That'll get you through a crutchton. That'll get you through a crutchton. And you can also use that with the C4 as well. That's one thing Simon Brown advocates. He says, hey, if you know those, use that in your model as well. So it's just a notation. It's a visual modeling language, applies to modeling in systems. It's used for expressing artifacts. It's based on object-oriented paradigms, so that works well for a lot of our languages. Developed by the Three Amigos, I mentioned these guys. Okay, Jakobson, again, known as the father of use cases. And so, what is UML and what is not? It's not a visual programming language. It's a modeling language. That's what you do in your architecture, your modeling stuff. Okay, it's not a tool or repository specification. It's a modeling language specification. UML 1.0, UML 1.5. Those are specifications for this modeling language. It's not a process. It enables processes. Okay, sequence diagram, we'll see what that looks like here in a second. We're enabling things with it. Okay, today's UML, this was just published not too long ago, just in April. I so agree with this, if you read InfoWorld. A good 70% of UML was a useless farce to sell overpriced, clunky tools. Looking at you, Rational Rose. Don't learn UML to go around annoying people with useless class diagrams. Do learn the basics so you can read a sequence diagram and learn to think this way. That's some pretty sound advice, actually. Yeah, don't go through and try to learn the whole thing. Don't boil the ocean. Just a few diagrams is just enough to get you to structure, and we can talk in a common modeling language together. As we got acquired by Cvent, they have 8 different platforms running at Cvent, 13 different languages. There's, I believe he said, a dozen different frameworks going on. Like, how on earth are you able to talk to each other? He says, we're kind of screwed right now. I'm like, that was a real admission of guilt. I was like, but I just got to tell you, because he already saw our presentation. I said, it says, that was one of our main interests. Like, this discipline, we got to get our arms around because it's a big thing for us. We have a lot of people that are on Java, but they can't talk to folks over on Rose here. How do you get it to a universal language? I said, right there, and let's bake it in. So that's kind of what Oliver's getting at here too, is, hey, just learn a few of these things. Just learn a few of them. That way you can have this communication tool and send stuff back and forth with each other. Makes a huge difference, okay? We're not going to spend our time on these diagrams, trying to keep them up to date or anything. It's just a tool. So we can avoid what we saw on those whiteboards earlier. It's just, oh my God. So use case is an end-to-end process description. Jakobson kind of came up with this idea. It includes many steps or transitions. It's not normally an individual step or activity. identified by the actor can log in. The actor can print a document. Print a document is a use case. Login is a use case. I'm just identifying by saying the actor can. What's an actor? That's what it's called in UML, but we've also known it as a user. Okay, but the formal way is an actor. Why wouldn't they call it a user? Why do they call it an actor? That was kind of interesting when I was learning. Why is that?
Doesn't have to be a person. It could be a
Why don't they call it meatware?
It doesn't necessarily, have to be a person, but it could be something playing the role of. In fact, when I did some work for Quaker Oats some years ago, when we did a use case model for them, we were doing some things with pet food, and the actor was a pet. It was a dog. It was trying out this taste system, and it would register in the software. So yeah, good case right there. Doesn't have to necessarily be user, it could be anything. Okay, so the use case has a precondition, an action, and a postcondition. So precondition is this is something in a system. Okay, so login. Precondition, I'm greeted by a prompt, waiting for my user ID and my login password. That's a precondition. What's the action? I type it in, I hit enter. What's the postcondition? I'm logged in, I see confirmation. There's the login use case right there. Everybody's been involved with that system, right? It's the most common one around there. Is that a design pattern? You bet. It's used everywhere. And when I'm at CVent, no matter where I'm at, no matter what platform, that design pattern exists. I could go and represent it by this. I just call that login. Okay? Common language. So there's this thing called essential and real use versus real use cases. So in essential use case, it's a very abstract, less detailed use case. Real use case, very concrete, more detail when I write up this thing. More information about it. So you can get as detailed as you want about your use case when you write that thing up. Okay, so that's the difference between an essential use case, real use case. So this is a very summarized, high level. The example I just gave there, that's kind of more of an essential use case. So login. I didn't go into the details about, do I got to remember the session? Should it be encrypted? Should I show the password? We're starting to get into more details of things. So that's more of a very real, as opposed to I'm just essential. Use case diagram. Anybody seen these before? Yeah? Okay. Nothing new here if you haven't, but okay, so this is what it looks like. So after I identify use cases, I start to put together a use case diagram. So I might have my use cases by stock, supervised store staff. My actor is a manager. My other actor is store staff. They can update status. They can make inventory report. You start to get an idea of what's going on in this system. Okay? This box around here is called a system boundary. And it's where all these use cases play into. We call it the inventory system in this example. So what we're modeling here is use cases that make up an inventory system. Can use cases extend each other and include each other? You bet. When I buy stock, I give payment. That includes that type of functionality. Buy stock can extend report quality issues to supplier. It can also include return damaged goods. I'm using some type of notation here to show what the heck this system's supposed to do. We do this today in Agile. We call them stories. But the challenge we get there is when we're using a tool like Jira, we put all this stuff in a backlog. I really don't get this, do I? It's only as if you're doing story mapping. Okay? Anybody doing story mapping with their Agile today? A lot of people skip that, and that's also one of the challenges out there. So that's also one of the other quests I find product management has really done well at easier is keeping some type of backbone of what's going on with this. Okay? So we want to also think of this in terms of a conceptual model. So the quintessential object-oriented step in analysis or investigation is the decomposition of the problem into individual steps, the things we are aware of. We call this a conceptual model. The focus of a conceptual model may show concepts, association between concepts, attributes of concepts. I gave two examples down here, and this is related to a flight system. So, yes, a flight actually has a date and a time. Real-world concept, not a software class or artifact. So my conceptual diagram, my conceptual model, that's what I want. Something real. Not abstract, such as flight database, date, time. This is a software artifact, not a real world concept. When you're abstract, when you're in some type of conceptual diagram, deal with your real world component. Don't start thinking in terms of your software yet. That's one of the things I see as people are starting to come from the software developer role into architect. Immediately, we want to start thinking like this. No, no, no. We want to talk like this here, because what is it we're trying to deliver for the business? What is it about the user? There's a user focus here. It's product management speaks like this. Business speaks like this. Get to that level. They don't care about flight databases, a record buried somewhere in MySQL, whatever. Okay? We'll get to that later. It's important. We'll get to that later, but not at this phase. Okay, so that's how you want to start with your abstraction. Decomposition into classes. And so in UML, a class is a description of a set of things that share same attributes, methods, relationships, semantics. You already know that from object-oriented programming. Operation of a service that can request an object to a different behavior. Here we go. Let's compare the two. All right, so this is more of the conceptual model here. I've got a flight with a date, number of time it flies to, an airport, and a name. Those are two potential classes, right? We want to get a little bit more concrete with this. We want to get more software oriented at this point. And so call out your classes and operations. Well, I've got a flight class that does have a date and time. It's described by a flight description. And what is this right here? We call these multiplicities. That's your notation. So for every flight, I have many flights, but one description, okay? I can also have a flight description, many flight description, that only flies to one airport, okay? So that's how you multiplicity. Early on, as you're putting this together, what are you essentially getting right here? Your data model, right off this diagram. It's coming right after as you identify your classes, how they relate from your class diagram. This is it. I remember when I was at Capella, the first time I had put this up to this conceptual diagram, my lead software guy had, he's really sharp. He looked at that and he knew what these were right there. He says, after we got everything done up there as far as the conceptual model, he says, we're already done with the data model. Just like that. And he had a reference for the thing. He was able to go sit down and take this thing and run with it and start putting it in a crutchton. Okay? And so it was great right there. And we also got to communicate this and find out from a business level, does this logic make sense? Why decomposition into a conceptual model? Well, decomposition is really an intermediary step. Going straight to classes is tough. I've seen some people try to go directly into classes as they're talking to their product manager. Like, again, don't think like that. Get your object kind of out of your head. Keep it in a real world terms. Put that into the model. And then you want to decomposition into classes. Then you can divide. There'll be plenty of time to do that with your engineering team or yourself or whatever. Okay, keep it at this real level and then decompose later. Okay. Tip, if you're struggling to find your classes or abstraction, go back to your conceptual model because you might have missed something. Okay, that's where it comes from. I keep mentioning this thing about a sequence diagram in UML. It's a real simple thing. It shows a particular course of events within a use case. Shows the external actors that interact directly with the system, shows the system events that the actors generate, and the ordering of events should they follow the order of the use case. And so actually right here, I'd have some type of actor can send a message. This class fires off of it. This is called a lifeline. Each class has one. These are probably what? Methods that are in that class. I'm calling them. Okay? And so we see the interaction between classes, how my actor uses the system. This is a sequence diagram in UML. It doesn't matter what language I'm in, doesn't matter what framework I'm in, but we can all talk this language. This is one of the key things, and this was what was so nice about it. When we had a lot of people cognizant of notation. Okay, so getting back to this discipline, it's huge. It's huge, and it makes a huge impact on things. So basic sample right here, cashier. The use case is what? Buy items. Oh, enter item. There's my method. UPC, quantity, how's that method work with the system? Can have an in-sale, make payment amount. We're starting to see how this all is enabled by what? The cashier. Okay, so I've got a visual representation of what's going on with this thing. One of the things we've got in our system is checkout. Okay? A lot of people got checkout in their systems. Modeling that in a sequence diagram in ours, it was huge. It was just ginormous. There was a lot of stuff. But what's interesting about it, it was just one single method that called a whole bunch of stuff going on in the background. I had to verify, had to go through payment, had to go through zip code. I mean, there's all kinds of stuff related to making a payment. And at the very end, there was a return method that came out. Success. Also works for front end. One of the things that's become more complicated here is our front end. We didn't used to have some of the front end complexities. For a while, I mean, some of the front end frameworks, you guys got involved with React, Angular, Vue, Embers. And for a while, those things were changing every 18 months or something. It just drive you crazy. It's still JavaScript at the end of the day, but why so many frameworks? And you go out there and look on NPM, it's the wild, wild west. There's a bunch of stuff going on out there. Wouldn't it be nice if you could actually model the front end on this and kind of reduce some of the complexity and make it work with your framework? That's kind of what the sequence diagram will also do. So I gave an example here too of how we could essentially have the user piece going in with this and then communicate with the back-end application, whatever's going on here. I could expand this out to multiple classes where it's check login, validate login. All of this is coming back from, this is probably what? JavaScript right here. Okay, what's going on? So I'm modeling the front end. And at the end of it, yeah, save the user. Goes back to the database. Again, same type of diagram, sequence diagram, right? Let's talk about this other diagram, class diagram. So it illustrates the specification for our software classes, shows definitions for the classes, identifies the classes participating in the software solution, and shows the class relationships. That's an interesting thing. When I take a look at one of these large code bases, that's like one of the first things you're kind of going after is like, what does this class do? What's it about? This is also a point where you see some of the worst designed software out there too. It's like, what was the thought behind creating this class? And look what it's evolved into, some monstrosity I can't begin to follow. And without a visual representation to tell me what the heck is going on, that is damn difficult. In particular, can you imagine coming out of a 12-week dev boot camp, and your background was originally, I don't know, archaeology, that's what you got your degree in. You don't have much of a systems background, and yet you're wanting to get into the world of software development, so you did this boot camp that you paid. All right, anybody go through boot camp? Okay. That you paid 20 grand for. And it's still tough to find a job. Once you land the job, you get put in this huge code base, and now you're trying to figure out these classes that you figured out in your dev boot camp, and it just doesn't make any sense at all for a long time, and you're always having to go to help because who knows this? Who knows how all this is running? That's probably been the guy or gal that has been in this code base for a number of years, been working with it. They've traveled all the different places in the code base, and it's still up where? In their head, because they haven't created any of this stuff yet. Is their job secure? Who cares? How secure is the company at that point as that person walks out? You're just now doubled the amount of money you're going to spend here to try to get some people up to speed, try to figure out what's going on. This is an investment over time. This is your vitamins, right? Are you taking your vitamins? Remember that I said at the beginning? It's almost as if you just ended up on the OR table as that person walked out the door. You're on the operating table, you say, oh man, we should have invested in our vitamins. I hope that makes sense. It's kind of a goofy analogy, but I'm going to run with it for now. Use case, or scenario in the Crutchton, right? Buy items. Look what all's involved with buy items. I got a store class, I got a post class, I got a sale, product catalog class. What makes them use each other? What looks in? What houses? It's showing the interactions. It shows the multiplicities. This is the class diagram in UML for buy items. I'm also showing instances, variables, methods, all these different things. What is it about that's interesting about this class? It's got methods, but it doesn't have any
Data.
data. Yeah, nothing there. Same thing with this one, product catalog. It's got a method for specification, but not that. How about this one, product specification? It's only got fields, but no methods. I can do that just from, I haven't even looked at the code yet, and now I know that. I really don't have to know much about Perl or what language this is in. I immediately got that from this extrapolation from there. Huge help in knowing what's going on in this code base. Okay, so that's kind of the power of this thing. Remember the statement I showed earlier? It says, like I was saying, don't waste all your time with all these useless class diagrams. In a way, he was kind of right, because when UML was out, it was not uncommon that I would see a class diagram with over 300 classes on it. And it looked like the biggest spidering web ever. I couldn't begin to follow it. That was somebody that did not study UML, just kind of, oh yeah, I did this, and just started writing out everything. You got to do it in chunks. You got to do it in small pieces, and that's where the iterative process comes today. It's back to the Simon book called Just Enough. Just enough to get through the sprint. You don't have to design a great big thing. Component diagram. This is the last one we're going to cover. It's useful because it gives us a high-level architecture of what's being built. Allows an architect to verify that a system's required functionality is being implemented. As a UML 2.x, components are now strictly logical, design time constructs. And they actually call these constructs now. But since we're on 1.0, I like calling them component diagrams. If you use Glyphy or Visio, guess what the little menu's going to have on it? For UML, it's going to be called a component diagram. If I were to go back to that use case diagram that you saw with the actor, and it says use case name, what version of UML is that?
1.
1?
Doesn't matter.
Anybody else? The answer is, it's all of them. But that's where it came from, was 1. Yeah. Yeah, so, yeah, 1 covers so much from the beginning and everything. What was added later on in UML was additional diagrams to get us out to that generative software for rows to generate code base and everything. So we had relationship diagrams, we had class split diagrams. It got insane. Everything too bloated. No, we just need the basics. Okay, just the basics of this thing. Okay, an artifact can be a physical unit, a file, gem, modules. Yeah, we're on Rails, and so it's not common for me just to put some gems up in a component diagram. Show me how this gem. This is what the internationalization gem. It shows how it works with my home page. Okay, interact. So that's all that gem does. IETNN. Okay. Similar things in Java, similar things in PHP. Yeah, you guys are familiar with it. So this is a component diagram, and in the Compile world, we have something called vendor portal applications. So if I'm Nike, I'm a vendor. I've got a place you can come and have your event at. If I'm Regal Theater, I've got a place you can have your event at. I'm considered a vendor. So I would go into the portal, enter in my information. One of our key vendors that we've got is Regal Theaters. A lot of people, last December, for the release of Star Wars, wanted to have their office sales party associated with that. So we partnered up with Regal because it is really tough to get people in the theater on a Monday afternoon or Tuesday afternoon when they're all at work. The theater's empty. So when we show up and say, hey, we got a deal for you. We got people looking for space that they would love to go to during that time of day and have their business meeting. They said, let's hook up. And so on the release of Star Wars, we had 92 events across the country, all booked at the same time for that release party. That's what is going on in the vendor portal, is you can sign up for this thing. So you can create, you can almost describe what's going on with our software right here. So yeah, you go in and create a group. This is a form you submit. There's a can gem. Anybody familiar with Rails? That's your authentication. Okay, that's your authorization. That's what allows authorization in gems. That's kind of the gem that controls that. It used to be called can gem. The first version of it was called can. We're all placing bets on what version 4 is going to be. I'm saying quad cam. Group AR model, Salesforce.com. Yep, that's also part of this. Google Maps. Well, yeah, where's your venue at? Yeah, I tie into Google Maps with this too, right? That's what I'm showing with this. So I'm using the API out of that. And group information out of Salesforce. You signed up as a vendor with it. You have a master service agreement. Yep, I'm connected here. That's also part of the form that I'm submitting right there. So, yep, there's a whole flow about component-wise. I'm talking APIs here. I'm talking gems. I'm talking different components. Okay, the library. Right. So, what are the 3 diagrams again? Sequence, class, component. Those are the 3 you need to know. That'll get you through a question. Be familiar with what a use case is. You already used stories today. Same type of thing. Okay. In that question diagram, you have physical view. There's a. Is anybody using Cloudcraft? Cloudcraft is used for modeling your AWS infrastructure. You can actually have like a 3-dimensional thing that shows all the components you're using out in AWS, and each component will show you a costing of how much it's costing you each month. You can make the entire drawing of your AWS system on Cloudcraft. Okay? We've taken Cloudcraft and we put that in our crunched-in physical model. We just, boom, take a snippet. Oh, this one's running on an EC2 instance for Gemini. That's the name of our source. Pop it in there. That's associated. We know where this code is running. That's another thing. Coming into a large code base, where is all this stuff running? We've got 7 different instances out in AWS that's splitting up this application. When I came in, like, why are they all there? And the guy starts to draw me one of these dashed lines. I couldn't begin to follow what's going on. Show me this, and now I know where it's at. Show me a physical view, boom, right there. And when I just hired an engineer a few weeks ago to come on board, he just looked at it. I said, describe the system for me after reviewing these things. He said, so we've got 7 instances. We've got redundancy because they repeat. He just went through the whole thing. I said, how did you know that? He says, well, it's all in the crush sheets. Like, he looked at me like, what are you, an idiot? You know, on there. Physical diagram. And this is, again, this is what I'm showing for infrastructure. Okay, so even if you're using like your Jenkins instance out on EC2, we've got Jenkins out on EC2 on AWS. We've also got a zip file that's uploaded here to our S3 bucket. AWS Elastic Beanstalk for my load balancing. Okay, how it triggers. Those are all part of your physical deployment diagram. Okay, so let's talk a little bit about how we doing on time here. So clicking right along today. Okay. So design patterns. This was something that was very popular early years, and on that timeline, you'd see it start to evolve somewhere in the 80s, and then 90s. Patterns became very popular, and then pretty soon, as the turn of the century came around, Y2K or so, we'd start to hear components being used. And these were all the things we knew about building software. And then pretty soon, as we put a bunch of components together and diagrams, you started to see an entire framework. And that was the genesis of where we got Django and Rails and things like that. And that's how it came about. So patterns is what we used to work with. And today, we still use patterns, but in a different way. They're very simplified. And so in software engineering, a design pattern is a general, reusable solution to a commonly occurring problem in software design. A design pattern is not a finished design that can be transformed directly into code. Rather, it is a description or template for how to solve a problem that can be used in many different situations. It's this repeatability. Okay, that's your pattern. I can use it in many different areas. Login, right? That was a pattern. Okay, that occurs in many different places. Okay. Patterns originated as an architectural concept by Christopher Alexander around the late 70s. That's where this came about. Okay. GOF. What does that stand for? Gang of Four. So some of you guys are familiar with that. So this is one of these things, again, back to earlier years of object-oriented design. Design patterns, they gain a popularity through this book, actually, called Design Patterns. And it's really about making object-oriented software in this kind of reusable type of thing by the so-called Gang of Four. And so the book's authors are Gamma, Helm, Johnson, and Blitz. I've always struggled with this guy's name. Mercedes, yeah. Those are the Gang of Four. This book became very popular and is still referenced today. It contains a lot of the software patterns that are in our systems today that, quite frankly, we don't have to worry about anymore. It's baked into the framework, everything. But that is how a lot of these systems got put together. And so every once in a while, I hear somebody reference a Gang of Four pattern. It's like, oh, that's kind of interesting. Somebody understands this and have really studied it. So patterns are an interesting thing because there's two arguments that go on with this thing. They're supporters. Why do patterns? Well, okay, design patterns can speed up the development process and productivity by providing tested, proven development paradigms. Okay, seems pretty simple in concept. Critics, why not do patterns? Well, they're viewed as workarounds for core features missing in a language framework, or sometimes viewed as a lack of good abstraction and a barrier to creativity. Well, if I keep using this same paradigm every time, am I kind of stuck in that design type of thinking? Do I necessarily have to think of login as login? How about I just walk up to it and start using? Somehow or another, I'm already good. I'm already authenticated. I didn't have to log in. It's stretching your mind to a different type of thing. That's the argument with it. I myself, I still like thinking login. If I walk up to my keyless car, yeah, it's a nice proximity, but I'm still using a key. Okay, fob. Certainly not turning it into. But that's the idea here. I think both sides have a good argument with it. This here is saying, hey, productivity, these are the people, I want to create stuff right now, and I'm going to use the components that are available to me. This here is somebody saying, I want to think outside the box. I don't want to get stuck in this thing. Good arguments for both. Yes, sir?
I think for me, the bigger argument for patterns is communication.
Definitely.
Right, because you can, if you're all using the same terminology, you don't have to go to the whiteboard and you can just say what the pattern, we're using pub sub to have these systems talk to each other. Okay, I now know immediately what you mean. if you know what the patterns are, right? Versus, well, I'm going to open a socket and we'll send some messages and we'll negotiate, right? You could, that's the anti-pattern view, is you'd have to go through that description.
You know the drill, right?
Oh, sure.
Yeah. And it's a good point you really bring up, because think about 2001. That's when we had, the 17 guys getting the ski lodge and come up with the manifesto. What was popular at that time? Patterns. Gang of four. This was it. Gang of four. That was it. Those guys were thinking in terms of pattern, and they did exactly what you're talking about right there. There's ability to communicate with that. Fast forward 18 years. Ooh, different kind of thinking going on now. Yeah. And it's just, we don't think really in terms of so much of that. If we do, I hear the term pattern almost being abused at sometimes. Somebody will call something a pattern when it's not. It's just a programming paradigm or something thereof. So, either way, 3 pattern types. So there's creational patterns, structural patterns, and behavioral patterns. Those are really the main 3 you need to be familiar with. Creational patterns are once created. They create the object for you rather than having to instantiate objects directly. This gives your program a bit more flexibility in deciding which objects need to be created for a particular case. Structural patterns, this is getting back to our class and object composition, how inheritance is used. Behavioral patterns, specifically concerned with the communication between objects. Those are the main 3 pattern types. Okay, so creational patterns, structural patterns, behavioral patterns. Login, which kind is that? Which one would that be? You got it. Yeah, behavior. It's something I'm interacting with. It's going with the system. And so it's a behavioral pattern. Okay, so that's a little example of how that works. Okay. Architectural review board. Any of you guys have an architectural review board? Heard of it? Okay, so one person saying yes. Why do an ARB? Architectural Review Board. Well, ultimately, we want to align design with the company's business goals, strategies, and objectives, improve the quality of our products, find the technical design standards, policies, and principles for the company overall. Something I started at Capel was an ARB, Architectural Review Board. When I came in, our grooming session went for 3 hours. Like, my gosh, that is crazy, having a grooming session that long. What are we talking about in here? And as I started listening in, there was a lot of discussion about architecture and design going on. They were kind of blending grooming with envisioning. And there was just a whole melting pot of stuff going on with it right there. So I thought, let's pull that dialogue out into something as a focus group. And let's think about our overall holistic view of system architecture and application architecture. You can call it SysArc and AppArc for short. So when we get our architectural review board together, we meet once a month internally. I've got a few developers that are in it. I got one person from QA. I got one person from DevOps. These folks all are interested in architecture. It's part of their career roadmap. I've worked out with them. They want to talk about SysArc and AppArc and what we can do to guide the direction of our system, design it, so we don't have to talk about this just abstractly in some grooming session in Agile and everything. So it gives focus to it. But this is not just me putting this together. There's actually a format around this saying this is where ARBs became very popular. MIT is probably the most well-known one, and this is the format we follow with this. There's a couple links to this I'll have in the presentation for this. And really good MIT ARB guidelines for this. When I was at, I worked for Brightstar as well. We also had an architectural review board on this. A lot of companies have these. It puts a little bit of focus on this omnipresent but not visible type of thing. It gets a little bit of focus on this thing so we can start to guide how our design is done. Everything. It works great. We also, part of this, we have an issues log that we're always reviewing too. If something structurally comes up, hey, let's put that in the ARB meeting this month. Or hey, I want to talk about something in C4 model. Or hey, as we come on board with CVent, they're using Scaled Agile Framework, SAFe. That has something in it called an architectural runway, where you do enablers and you do functions. You build just enough design, consume. Build, design, consume. That's called architectural runway. It's safe, and that's one of the things we introduced in the ARB. That was new for a lot of folks right there. It's getting back to that principle of design just enough for that. Not really well spelled out in the original manifesto, but certainly in the Scaled Agile frameworks, we're starting to see that spelled out, and they want that piece in there. The big question mark is, what are you doing during all that? Well, it's a lot of stuff we just talked about. these are our ARB goals. They kind of sound a little corporate-ish, but these are really actually just taken right out of the MIT portion. They're short-term goals. You still want to create this agile mindset, create architecture roadmaps that support your business. Long-term, prevent framework bloat and achieve a platform that can be easily maintained, maintenance. Okay, being strategic, being visionary with the thing. Okay, reduce the long-term technical debt. That's also something we've addressed in our ARB with this too. Is like, at what point do we need to take on our technical debt? How can we avoid it? One thing I've noticed is we've started doing this for the past 6 months. Put that small design piece in there. I've noticed the amount of debt that piles on. Man, has that really shrunk? Because we're being very strategic and thinking ahead about our design and putting it out there. We don't have to just patchwork something along just to get to another place. Okay, so we can think about it, plan ahead on the thing right there and say, nope, it's out for the sprint because we don't have enough design around it. Okay, cool. We don't have to patchwork it and say, well, we'll catch up on it later and just call it technical debt. Let's go ahead and build it. Say, oh my God, it just builds up and it's just crazy as hell. And this keeps our technology costs in mind too. That's a big thing with ARB. We have, everybody, you guys on AWS, some of you running on AWS, you've got an AWS bill, Azure bill, Google bill. What's the other one? Vima, I think is for the healthcare one. They get to be pricey. You can spend easily hundreds of thousands of dollars, millions of dollars out there in the cloud. But how do you know you're not purchasing too much? How do you make sure it's right? How do you make sure it's lined up? This is one thing that your ARB can do. Find out sysarc. Always be modeling sysarc, and it's a key thing here because you want to start small but plan big. Don't try to boil the ocean. Focus on quick wins. Show your results early and often, with the end in mind, and then create a maturity roadmap and follow it. Okay, we're talking enterprise architecture and frameworks. When you think in terms of enterprise frameworks like cities, think of enterprise architecture as a city, portfolio architecture as a street, system architecture as the building. Okay, so kind of the architectural continuum. That's one way of framing this in terms of that. Enterprise architecture. Enterprise architecture is a strategy to minimize IT and business mistakes. Many competing perspectives, approaches are to EA. Here's the key thing. There's really no single agreed upon enterprise architecture standard like we do in AppArch. AppArch, we got UML, we've got some models out there. sysarc, not quite the same way with enterprise architecture. So that's a key area you want to focus upon. And so that's why we've got these things called architecture frameworks. And so just like software frameworks, there are enterprise architecture frameworks. And these frameworks help us be productive in creating and managing our designs. The main frameworks that you use from, we use Togaf. I really like Togaf, specifically Togaf Adm. This stands for the Open Group Architectural Framework Application Design Model. Okay, and I'll show what that looks like here in a little bit. Some folks are familiar with ITIL. Zachman was popular in the, I believe, early 90s or so. It's more like a grid, a 12-piece grid, and it shows you how you make your decisions based on your enterprise. Somebody had asked me what this one is. This is a Department of Defense architectural framework. This is for software as they write it too. So they follow their own framework as well. So there's a mil-spec on their enterprise architecture. And a lot of the older systems, even that the missile systems are built in, their software follow this type of enterprise architecture framework. So we use Togaf, the Open Group Architectural Framework. We're currently on version 9.1 with this. Anybody familiar with anybody using Togaf? Is this first time you've heard of it? Okay. Yeah, a lot of this doesn't get the airplay that it should, as it did kind of back in the day. So it's key because it's the go-to framework for enterprise architecture, and this group kind of maintains it. What you do with this thing, and this is how we run it in the ARB, is when I start the architectural review board session, we've got kind of a simplified version of this because a lot of these guys were still kind of new to this, so I've taken out a few of these things. But we start with the architecture vision. I'll have a slide on that, so what do we want to work on? We have something called current state, future state, technology vision, governance, and you can just walk through those, and that's what you're reviewing in your architectural review board. So you can say, hey, here's the current state of this system, here's what we need to address, here's future state, what should we scale to, what are we expanding to? So you're always reviewing this, in every ARB. We go through this thing, it's called the Togaf Adm, Architectural Design Model. And we walk through that every time. And it makes a big difference too, because one of the governances we've got here is actually coming out of Europe, which is the GDPR. Okay, familiar with that one? Yep, right there. Part G out of Togaf. That's where you want to address that. Okay, so standards like that are key. So we always keep those in the highlight. Anytime somebody wants to bring in a new technology, introduce it into our stack, it goes through this whole thing right there. Let's run it through the gamut and see what happens if it makes sense for us. Is it a sound decision to make? And so we do that. And that is it. Questions?
This is a whole bunch of questions. It's a very good presentation. Thank you. First of all. That's kind of because we went from many years ago, went from waterfall into kind of agile world, and what we ended up doing with our stories is actually making design of required artifacts, and they would just get scheduled in. They get pointed and scheduled in, so we stayed on a 1 week sprint, but you wouldn't maybe consume that artifact until the next sprint.
Yeah.
And I'm wondering, is that reasons against that, or because you just decided to kind of, it sounded like, we'll make our sprint 2 weeks and you'll front load those tasks in the early part of the sprint.
In the early part of it, yeah, and for that reason, so we give ourselves some architectural runway, as you call it in the Scaled Agile framework. So you want to create a runway. So we're actually planning for the sprint after it in that. So when we got things going on, for the very first one we did, I put in the design for what needed to be put in. And then we started from there. And so as we go to the next sprint, the design work that we're doing, we already did it in the previous. So that helps with product management to plan what's coming out in the next release and everything. That's just the way I kind of decided to do it there. I noticed in the 1 week sprint, there wasn't a lot of time to discuss and get our arms around it. And the chunks ended up being so small just for where we were at. I wanted people to also learn this too. So it gave some time to adapt to this, because this was something kind of quick. And given how much points we're rolling over each week, it became apparent to me we're trying to bite stuff in too large a chunk. So we didn't know how to decomposition. We didn't know how to decomp stuff. And that's because we really didn't know how to design. We really didn't know how to chunk this up into a visual representation that could show, oh, here, let's just do this, put a crutchton around this thing, and let's see where that ends up, right there. Find out the dependencies off of that. Find out what happens in oftentimes the story mapping. Okay, so the dependencies on a story mapping. Story mapping has this thing called a backbone in it. A backbone gives you this holistic view of things, and this is where your stories come out of, and you start to see the cards come out of the backbone of things. But those were just kind of some of the reasons. It's no one particular thing, but if it's working for your group, if you feel that's enough time to get, depends what your delivery is to be. But we've had to split things up, but I've gotten away from it. I will tell you that, because I don't like having something partially complete, because that's only a partial design. I'll first ask that we can design a good chunk of it in this sprint. Let's not start building until we get a good feel of it. We'll go into the next sprint and continue on with the design that we pick up. And it might be just enough right there. Okay, let's go for it. Let's go ahead and build it at that point. Then we don't get left hanging in the middle of something where we didn't get through all of our design thinking. Uh-oh. And then there's another requirement that comes in. Somebody changed their mind and everything. So it kind of prevented that. And so that's why I stretched it out a little bit farther. So it gave me a little bit more runway. Didn't want to go to 3 weeks or 4 weeks. Well, it causes a lot of anxiety for people that are coming off of a 1 week sprint, for one. But it also, I think the 2 week just seems to work just right for what that company was doing.
Sure.
When I was at Brightstar, we had a three week. We started with a 4 week sprint. But there's a lot of people coming off a waterfall too. It's like, oh my God, that's reel that in. It's like, can't we make it go longer? It's like, well, what are you trying to do? It's like, well, I want to get to this. Like, well, don't we have enough to go here? Well, yeah, okay. So yeah, it's a minor adjustment on that. Good question.
Thanks.
Yeah.
Can you speak to Kanban, this we run 2 week sprint cycle? And we had the carryover every sprint, that never bothered me per se. But we totally just abolished this. We never had carryover.
Because you're on Kanban.
Yeah. I think we're not true fully Kanban. I think we're like this weird hybrid that we kind of came up with. But
Isn't everybody?
yeah, all right.
I have people within the sprint do Kanban. If I have something, I'll split out into a couple sets of teams. Like we've got one area that's just for project, what we call project intake, and then another area was vendor portal. If that team on vendor portal wants to work as a Kanban, because you already know what the work is going to be and everything, you're all confident in your time management as well as what's coming up and what's expected, then that's fine to work in there, but you're still working in the context of a end release date on things. The biggest issue I find with doing the Kanban really comes down to time management. Because I find some people will just crank. I mean, just give me more, and then go back to the pile. Give me more, give me more, give me more. I've also found it's just a perfect way for a slacker to be in there and just, oh yeah, I did mine. And it depends. I've had developers, in fact, not just development, but also on the factory floor where you've seen Kanban implemented. When I first came into engineering, well, I came in as a design engineer working in manufacturing, and we'd have people on the factory floor, and it was a Kanban system. And I'd see people out there taking breaks galore, not really getting the work done, but yet I'd see some people out there cranking and running out of parts and stuff. So it became a management issue of really, can you manage the time to make sure that that's effective? In terms of design around Kanban, yeah, design as much as you can for however far we want to go. Now, mind you, I don't want you designing for the next couple weeks on it. No, how far do you want to meter the Kanban that's going out? So think ahead of that. And so as I work with those guys on the Kanban piece, it's really metering the design. You're still thinking in terms of releases. You're still thinking in terms of releases. So maybe a grouping of a function as you put it together in your story mapping. Right there, okay, I want to take this segment here, and we'll Kanban off of that. How much design do I have on it? Okay, you can still segment it at that. You just don't have this formalized, woohoo, we're going to release on this date, have a retro and things of that nature. So again, time management kind of a key piece on that. And one of the things I worked with our team on was, remember the Covey, the 7 Habits of Highly Effective People, very popular series right there? The time management tool in there, still very popular today. It's the 4 quadrants. What is it? Important, not important, urgent, not urgent. You want to work on things that are important but not urgent. You want to move things that are urgent, important. Stay out of that. That's management by crisis. Continue to move them into important but not urgent. Some folks just really struggle with their time management things. So just giving them that tool right there, help prioritize the stories. Next.
You mentioned earlier about getting your team together, and one might go out to the board and present one view or one everything like that, and then the other one will come up. Now, is it an architectural role for an architect? In other words, what is this team? Would it be, for example, developers coming in and taking on some of those responsibilities, or is this design work primarily handled by architecture and then presented to the team? How does that work?
Good question. Yeah, it's a really good question, because where is this architectural role at today? What do we call an architect today? So when I come in, I'd see people that have got that title, architect, and I'll ask them about Crutchton, UML, Togaf. Okay, well, tell me what architecture is to you. And for some of them, as we're looking at Rails, well, instead of creating everything in this one particular folder, we've decided to add another structure in here so we can put our config files into this section here. So we've changed the overall architecture of how we work with Rails. And that's architecture in my mind. I'm not going to argue against that. Yeah, okay. But no. So where I start with is when I do career planning with folks, like, what is it you're wanting to be? And I'll pick out the developers and say, I'm interested in being an architect. And then I'll sit down with them and we'll go over these tools, these kinds. Just like what we did here. In fact, this presentation was the very first one I gave to them right there. And so they just had exploded on things. And I said, let's just go into some baby steps. So let's first start off with doing a sequence diagram. So one guy I had who's been there a while, he knows a lot of the software in his head. he's often gonna be the one talking, so I said, just go up to the board, can you put a sequence diagram around? I'll help walk you through it. So it's pairing, it's architectural pairing, so I'm kind of instructing how to do the sequence diagram, how to do the component diagram, and then getting this in the classes. And what's interesting about it is, when we're changing something in the code base, he already knows which classes are there. He already knows the structure. For him, it's just downloading and getting it on the board in a language that the rest of the developers can understand. So what I'm doing is I'm picking out somebody who has an interest in this discipline, going farther down there. They don't know it right off the bat, so there's some coaching, architectural coaching that goes on with it. And it doesn't take long. It doesn't take long at all. And if they're really interested, they'll do it. And I still have to prod some of them to get to the board because they're not real confident in a couple of things. One is still getting comfortable with this, but two, trying to figure out the problem itself because, man, here's this big ball of mud of code. It's just, man, that is a lot to juggle and everything. So as we continue to just keep going, it's something you're building. It's a living thing, just like your code base. Your design is a living thing. You're building upon it. We're not going to create Rome in a day, just little pieces. And after a year, you look back on this thing, collect all those, you got a pretty good view of what's going on. And you've also got better on your engineering chops with how to diagram something. Everybody on my team knows what the question is. In fact, we had yesterday, the weekly team meeting I had. I'm going to be hiring more engineers. We're looking at bringing on 8 more engineers for our team because we're going to scale Kapow to fit in the C level. We've got about 1,500 customers. We're going to scale to 25,000. One of those customers spent almost as much as all those 1,500 we have. So 25,000 of those things. So we got to scale some people. And so as I bring people on board, that'll be a key piece that we want to get them acclimated with and everything. So yeah, that's.
And so it sounds like a key aspect there is to look for individuals that, that see this as a potential career path, or maybe even not that, but just show a desire to think a little bit differently. In other words, you can be a coder, you can be an engineer, you can be an architect, type of thing. And then just kind of encourage that and mentor that. Because that's what I'm going to say right now. A lot of times I think people are comfortable with just having everything handed to them without being part of the analysis. And then how do you be part of the ownership of that product that you're building? You don't understand it.
Yeah, if it's like this statement that Simon Brown made. If I can't visualize it, then how on earth am I going to be able to improve it?
And along those lines, at some point, you can't have every developer in your barn work at the architectural meetings, right? So you have to have mechanisms for disseminating what your group comes up with to the masses, so to speak. And I was curious about, and I know I asked you this before, but I'll ask for this group. Do you put things into motion to make sure that the end source code is somehow linked back to the architecture? Like, is it in the heading? Do you make them put stuff in the heading that says this piece of code was generated based off of this UML model or that sort of thing? Or in another thing along those lines is if you're programming in a world where you have to conform to specifications like data transmission specifications and stuff like that, do you include those in your diagrams? And do you just do you provide a mechanism for actually linking it to the source code?
That's question number 5.
Yeah. I'm done.
It's all right. Those are all good, and they're relevant and related to each other because that's an important piece. How are we managing this? What's the tooling for this? So how we go about it is Jira. Okay, that's our main ALM tool, right? Application Lifecycle Management tool. We've also got Confluence. I mentioned we're using Glyphy. So those diagrams some of the ones that you see up there, I did those in Glyphy. And so after we go to the board, I'll take a picture of it. I'll take a picture of the thing, and then I'll go ahead and enter it into Glyphy by using the UML notation that's in Glyphy. And I'll create that into a digitized thing right there. That's just I'm trying to get some guys up to speed where they can do that. They're able to draw it up on the whiteboard, so we've got to get to where they can use it on Glyphy. And one of them, he's gotten to be pretty good with it. And so that's one step. So get it into Glyphy. Now once it's in Glyphy, I can tie that into Jira because it's the same platform, right? It's part of that Atlassian stack. So I can put a link to the Glyphy diagram in the story, right there. So as I'm looking and reading the story, like, okay, I'll click on the diagram right there that maybe the architect went through and now see how this is designed. So it's carried with it. Same thing with the UX guy too. His comps are also in the story too. We use Figma for our UX design, and so we have comps in there. So what's being followed in the story is really central in Jira. Okay, so I made a link to my Glyphy diagrams, which has a Crutchton in it. Okay, it's got my UX diagrams, and if you've got standards in there, then that's going to be part of the story write-up that's in there, and I can put a link into something that's probably out in Confluence that I've got linked up, and I don't know, that's how we kind of tie it together. I don't know if you guys saw that, was it 2, 3, I think it was 3 weeks, somewhere, I don't know, 2 or 3 weeks ago, Atlassian released a product called Glyphy Project. Anybody see that announcement? This has got to be one of the coolest things I've seen, and Atlassian gets it. They understand this gap going on, by the way. I talked to a couple of these engineers on the phone, like, where are you going with your product? He says, we're going after design. It's like, because IBM's going after everybody else, because we see this gap, you know. And so they came out with Glyphy Project. What Glyphy Project is doing is you can take a diagram that you created in Glyphy, or a picture that I took of the whiteboard, just a JPEG, create a hotspot on the diagram or the JPEG. That hotspot I can tie to a card, to a story. And it's drag and drop right onto the visual right there. And so as I've got my use case diagram, as I've got my class diagram, whatever I'm going to be working with, any type of diagram up there, I can put a hotspot on that diagram and literally drag the sprint number, or the story number on top of that thing. So what I got there is something to visually tie it together right there, which is kind of cool. What's really telling about the way Atlassian did this is when you read the literature about what they released, they're trying to address a tool for project management. And they show this flow chart of how you're managing the project. Okay, it's a nice little business flow chart, and it shows how you're dragging your stories over into the project. But when you go watch the video that they're promoting this thing with, there's the real telling thing. It's only a minute. It doesn't show anything. It shows a system architecture diagram. System architecture diagram. Mind you, this is the physical view in a Crutchton. They took the sysarc diagram of somebody that's got their AWS diagram and showing that as the diagram that they're dragging their sprint stories into. And it's pretty cool because my DevOps person is going to be sitting there saying, oh geez, here's my task for what we're building right there. And he continues to build up on that diagram for future state for what we identified in the Togaf right there. And so he's got his diagram, he's got the sprint with all the stories visually tied to the hotspots in the thing. And then the product manager can look at this thing too and say, oh, that's where all that's running at. The whole thing ties together like that. Pretty cool stuff. That's the only ALM tool out there right now that has that, to where you can couple together visual with the actual assignments on top of it, and it carries it through. So I think it's a great product, and it's something I was able to talk my management into saying, let's make a pilot on this and let's see. So thumbs up, we're going to give it a shot and see what happens here. I'm also trying to push for a backbone too in the story mapping. So story mapping, another thing. Yeah.
Sitting there, I'll give you this question. How do you keep the documentation in sync with sequence diagrams and everything as like bugs come in, or like if it's something you can work on historically in the past or come back, making sure that documentation doesn't become like outdated?
What's the documentation?
Yeah.
That's the question. What's the documentation? So is the documentation a diagram that we created? Is the documentation a story that we previously worked on? What's tying all this together to where it's not dated and we don't have to stay up on the maintenance? Is that the angle?
You know, let me just ask, like, do you like reference rating the code or something like that to look back to the actual design, like what generated this code?
In Jira, when you do your code, okay, you can link to the release, right? In the Jenkins, the repository. So you can tie right to the repo and see where that's at out in GitHub. So it's real, I said Jenkins, but it's GitHub. So you can tie into Git and see what's the code attached to that story that's got that design diagram in there, that's got maybe the UX portion on there. Now, as time goes on, if we're updating stuff, I can go back to that one. Yeah, I can go back to it. If it changes, in a big way that I don't want to go back and redo that thing. But that's fine. I'm just going to go to the most recent. And I can still put a link in reference to prior. So they're always linked in some way. So you can always go back into the hierarchy of the history of the thing. And that's really what we want to see. Where did this thing originate from? What was the genesis of the thinking that got us to this code base? That's something we don't have, right? We're coming in this big ball of mud. I don't have anything. What made us decide to go this path? Well, as time goes on, you'll start to see the linkages for each one of those things. It's the most recent one that's up to date. My UX, the person that does our UX today, he was pretty excited about this Glyphy project because he said, I got components that I reuse all the time, and we've got a lot of repetition here. I'd love to be able to call those out on this thing so I can find when a new one is needed. Everything. So, and as one becomes obsolete, you can start to flag those things on there, right on his actual comps. So that's the system. I would recommend also taking a look at that Simon Brown book, Just Enough. He also has some good ideas in there. There's more than one way of doing this thing. Anything to avoid going back to what we were doing in waterfall, that is, we made these beautiful diagrams for the past 2-3 months, everything, and now we got to keep up on this thing, because we're not going to touch those things, because we're going to write code for the next 3 months, everything, and it's all dated. No, it's continued. It's a living, breathing thing with it. So your ALM tool is what's key. Jira, Confluence, Git, all these are key things that tie together.
So just to be clear, is that providing you some, like, if you're writing in JavaScript, it's giving you a header you can actually plant in that piece of source code that says this is, that, here's your architecture documents that support why this was written this way.
In the actual code base? Is that what you're
It's
saying?
not in the code, it's all related through the ALM.
That's right. It's related through your Jira ticket that you use to create that JavaScript code.
Oh, okay. So
So
you're
the code's
keeping,
checked in against that ticket.
Exactly.
So you know all the diffs that went
and you're
against
referencing the
that.
ticket in a Git transaction. something.
Yeah.
Yep, that's it. And you can go back in the Git repo and see what was deleted and what was added. Yeah, and that's a great tool too. I think Atlassian had a competing product, I think it's still out there, it's called Fisheye. They competed up against the repo and you could see what was changed, but GitHub does all that now. Yeah.
But for me, it never solved the design doc problem using Jira. I'm still, I think it's the question you were kind of getting at is, it's the doc just lives in a Jira ticket, so you can never find them again. And as soon as you add new features,
Where's it at?
where you can't. Joe, didn't you work on this code somewhere over here? What was the ticket number? And there's the guy who knows all the ticket numbers. No, there's always the guy, right?
No, you're absolutely right. And what you're getting at now is, remember I keep mentioning story mapping? It's creating that thing called a backbone in story mapping. There's a guy named Pat that come up with this thing, and you always got to go back to that because you'll see where it's at with it. That's a product management feature that's coming out there. What's product management doing to help you on this too? That's the other question.
Oh, they're worthless. So
Yeah.
That's part of it.
they just build the thing, get it done. But you were,
Well, to kind of build on that too, I mean, I work in like a very large software organization, so, there's like hundreds of thousands of Git repositories and different software artifacts, and like, I guess is like, how do you, maybe that's where the enterprise architecture comes in more, is helping keep that organized, because especially if you're a new person, part of the first immediate problem is just understanding what are the different software artifacts and which one is relevant to the particular problem that I'm supposed to be solving right now, just so I can even begin to discover where documentation is, or what I need to know, or how it interacts with other artifacts in this.
It sounds like there'd be a pretty good-sized team that came up with that much. So that's a good-sized engineering development group, or is that something that's been accumulated over time?
Yeah, I mean, well, I work at Expedia, so
Okay.
there's like,
Both.
thousands of engineers, right?
It's both. It's been over time and a good-sized
Yeah.
team
Yeah.
as well. So how are you managing the scrums? How are you managing the artifacts and that? Are you keeping them, all in Jira? So as you do your scrums, I know that I mentioned Scaled Agile Framework. There's Less, there's DAD, there's a couple of these others. I think Scaled Agile Framework is popular because it's using this architectural runway to keep managing it. So as you have, anybody doing a scrum with scrums out there? Yeah, varying results on that. what are the tools being used, how are they managing that piece as they're working with product management along the way? And as he kind of points out there, well, if it's somebody that's worth, you're only as good as what you're going to be getting in. Right? I mean, that's what it is. With all this, the real weak spot in it here is, if I don't have good requirements to begin with, or they're extremely vague, how far am I going to get? Zero. But that's also good too, because I'm not going to start building something I don't know enough about. It is much more difficult to write software for something that's just generic, as opposed to something that's very specific. Yeah, if I know the details on it, then it's a heck of a lot easier to write everything. It gets back to the Mona Lisa versus diagram, picture versus diagram. Very explicit. What is this view showing me? Everything. That's what the diagram's got to get at. But managing that whole repository of those documents, as you want to call them, design documents. If you're working with stories, well, where are those coming from? Is there some type of master document that, or a BRD, business requirement document that product management's working with? And that's kind of coming from their end. I'm always curious to see how they're managing that. There is a notation, if you notice, that was on that framework called BPMN, Business Process Notation, Business Process Modeling Notation. There's a notation that actually coincides with UML. And so that was one of the ways they wanted to tie together UML with product management. It's like product management's got its own notation set that ties in, and I can marry all this together with this. But how many product managers have taken time for that? And count on this many fingers. It just hasn't been. It's a discipline. Again, it's a discipline. But it's a very real problem. I don't have a quick answer for it. Yeah.
One of the other questions I had is, I guess some of the friction that I always felt when I was kind of studying UML in school a little bit, and then later, is, and maybe it's just like a UML specific problem, but a lot of the notation seemed very coupled to like a classical inheritance-based, like object-oriented programming paradigm.
Works well for Java.
Yeah, and as soon as you sort of get outside that, mapping the designs to actual, or translating designs to implementation kind of starts to break down a little bit. Or even if you can follow through, it doesn't really necessarily lead to like a clear, simple implementation. So I'm curious, sort of, like how you would address that, or like how your teams.
And I'm trying to see if I understand how this is being asked. So what you saw was something that was coming out of an object-oriented nature, right? What if you're not dealing with an object-oriented base? Let's say it's a functional program like Elixir or something, okay? You're working in Phoenix framework. So Elixir being a functional type thing. How does this stuff work? Because if everything's based on objects, how does that go forward? You don't have this notion of classes. Well, what is it that we have in functional programming? We have functions, right? That's one thing. So, yeah, that allows, we can absolutely break this down into functions as well. If you don't want to call it a class, I took a notation. In some of the Elixir modeling that I've done, I didn't call it a class. I just put it as, hey, that's a function, and then here's all the things with it. So that's how I adjusted it, and it worked fine. And so functionally, I get to see how that's put together. All of this was a genesis out of, as you saw in the timeline from Smalltalk, that's how we package stuff up. But that paradigm, that's not the only one out there. And it's a great example. What do you do with something like that? No, you can adapt it. It's still a structure. It's still a notation. You're still trying to convey an idea. Because, again, getting back to the very beginning of it, what is your product as an architect? The vision. The vision of what it is. And you're just trying to communicate it. That's all the diagram is doing. No more. That's it. So just communicate what that is. As you can see from all the scribbles on the board, we struggle with that. And so just try to standardize it. Good question. Very good question. And so what's the next language going to look like if it's not function or object? Well, it's still it. It's still how do we go about solving the problem, visually capturing that. That'll probably be a good opportunity to start another type of modeling language. If you're interested, give me a call. I'll see if we can find some funding for that deal. Because those guys got really wealthy. Yeah.
We've started a small team or small in group that has been started playing with domain-driven design, and they noticed a couple of the slides you mentioned leave the programming out of it and just use the business's terms to model the stuff in there. And have you worked with that at all? Have you been exposed to that? I mean, it sounds like you've been exposed to a lot of,
DDD?
yeah.
Yeah, so and triple D, DDD, whatever you got. So design-driven, domain-driven design here. And then what you were referring to was what we call a conceptual diagram. So when we decomposition it, it's before I go into thinking about code, before I go into thinking about a system, it's getting that thought process of what's the problem I'm trying to solve here because it's a customer or something like that. And that's really where our best developers come from. It's about solving a problem. So I want to be able to speak in that language. So if I can get up there and start putting some type of composition or diagram that speaks to business terms and how I kind of arrange it. Oh yeah, there's a flight, there's a date, there's a location. Well, I don't have to say it's flight, whatever I want to name the method as or the class or something. Don't think like that. It's getting yourself out into that thing. That was one of the challenges, I will tell you, that I had with an engineer, not at this particular company, but another one, was pulling him out of that. He was really heavy into the spring and really thought in every way of that. And I said, don't reference to that when we're at the business. I said, just strip it down to what does this class mean? And pretty soon he started kind of reading it. It was really interesting. He started kind of thinking of a different name for the class as he was talking about it that's how he's kind of translating it into a business term. And pretty soon he started to see the code in a different perspective because after he got done with all the business discussion, he goes like, why the heck did we put classes in this? Why did they do it this way? It's like, and you start to see how decoupled this was from the original thinking. So you don't want to be reversing it from, oh, I need code to get to my business problem. No, I want my business problem to work its way to where I can decomposition down into some package into classes, functions, or whatever else. Don't try to reverse it. When I came on board Capel, everybody talked about it in terms of servers. Gemini, Apollo, they named their services, Minotaur. And I still hear people reference it, oh, that's Minotaur. Well, what about Minotaur? That's a server, that's where the code lies. I don't know anything about that. I mean, with all due respect, it's something in this person's mind because they know what's out there in Minotaur. That's some instance on an EC2. And I don't know anything about it. Well, Minotaur is the front end piece. That's kind of where it's being served up. And then we've got one called Gemini. These are cute names, everything, but it's doing nothing for me from a visual standpoint. Or why not just call it vendor portal? Why not just call it client portal? Meaningful names. But it's cool. When you're this hip startup and there's just a few of us doing it, let's call it, SpongeBob SquarePants. I don't care. It's a goofy thing. Yeah, and that's just part of the maturity of it. That's just part of the maturity of getting it there and getting those people to think in terms of, don't think about it from the server perspective. Don't think about it from a code perspective. It's the function, and it really helps the business. I must say, when we get service tickets in, that helps in a big way because somebody's thinking like that right there. Because it's real tempting to think about, well, where at the code is this happening? Now, don't think about it. What is that person trying to do? Because you might end up finding out it has nothing to do with the code that's already written. That function just doesn't exist. Yeah, that's what it is.
And it helps with communication with the business too.
Big time.
Right, both directions, because you're actually using the same nouns, right?
Exactly.
If you're not talking controller, then it's nothing to the business at all. But if you're saying, oh, the user or
the
portal or whatever it is.
I got it. It's can. Oh, that's in can. Over on the business side, that was hilarious. I'm not going to tell you there was a joke that came out about kicking cans and stuff. It's just getting out of it, but that's okay. That's just part of the maturation curve, and that's what differentiates from how you might have learned something to thinking in terms of solving a business. That's what we look for in a more experienced engineer, right? So, yes,
so you mentioned that you use a correction and the C4. So when in the 2-week sprint would you put those together?
right at the very beginning.
Okay.
Yeah,
Like
right at the very
in the
beginning.
planning meeting or first couple days or? And who's involved in creating those?
Yeah, good question. Who's making the call when to have it, too? That's your Scrum Master. That's the Scrum Master. So Scrum Master's got to be a little cognizant. So I've had to work with that. We scaled our team down to 50 people, and the Scrum Master role is rotated. It's not a dedicated person. And so the people that have also become a Scrum Master might not necessarily know design or everything. So I'll go up and ask them as the engineering, the director here, say, do we need design on this? I'll ask it right up front, do we need design on this? And they'll kind of look at it and say, I don't know, do we understand what we've got to do here? And then somebody starts thinking about it from a system level. Somebody starts thinking about it from the app. Like, well, I'm not sure. And I say, okay, well, explain to me what we're going to do. There, yeah, go up to the board. Start thinking, and if it's a deer in the headlights, we need a design session. Okay, let's put it together for that right there. And there's not a lot of argument at that point because you can't go up and articulate it, right? Even though I may have my most experienced engineer just shaking his head, like, no, it's no problem. Yeah, I know exactly how that's going to go. Well, good for you. What about the rest of us? As a matter of fact, that person's one that's going to be going up to the board. and that's great because that person is also growing too because they're mentoring. They're showing and they're learning this skill. It's a win-win. Everything. So a little bit of a judgment call. If I don't have my hand on that, if I don't watch that, they will go right ahead without design and do the code, everything. So it's got to be an intentional thing. It's not an eyes rolling, oh, Brad wants to do design, for God's sakes. They want it, they get it, they understand that is an investment. They've seen the merits. And I've had two of those guys come in and said, we are now doing, 12 more points in each sprint than we did before because we can go farther with it. I know the depths of what's going on here. So we're more efficient because of this thing. So there's other stuff coming out of this right here. I've got a junior developer and she's always asking right there, are we going to do a design? Like, well, I know why they're asking. Well, yeah, they don't understand this big pile of mud. And they want that visual. That helps them. So there's other people driving it as you get farther along it. Pretty soon it'll be just part of our cadence in there. But getting that started, that takes some things, and you have to have some people that genuinely want to become an architect. I have one engineer, as he got to be familiar with this, he kind of decided, this really isn't for me. I kind of like staying in my code base. I like doing that piece of it. That's fine too. That's cool. That's absolutely cool. No problem.
So if we bring in just a senior of each discipline, like platform dev, web dev.
We're a small team, so it's like 7 people. So it's like, just
Yeah.
bring on even QA too, because what do they got? They got to write test scripts off this thing. Hey, what's this thing supposed to do? So, how are we doing on time?
We should wrap it up.
We wrap up? Okay. All right. We're good. So, thank you, everyone. Really appreciate it, and thank you for having me. So, a lot of great questions.
Thank you.
Good.
Thanks again.
Brad.